Okay, for this next video, we're going to talk about balancing chemical equations, and this is looking at the law of conservation of mass. Well, before we get started, we need to know that there are 7 elements that when they're unbonded with other elements, they exist in a bonded pair. So what are those elements? Well, they're hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And if we look at that, it looks like it's a 7. So it's hydrogen plus 7 elements on the right-hand side. And an easy way to remember that is by remembering the phrase, "Hail to the mighty 7." Okay, H for hydrogen in the word hail, and then the mighty 7 is the elements on the right-hand side of the periodic table that, when they're darkened in, look like a 7. So those only exist as what we call a diatomic element. That's one of your vocabulary words. If you'll write that down, diatomic, Di, just like the prefix di, means 2, atomic referring to atoms. So for those it takes 2 atoms bonded together, and that's how they exist. So we see this here in this first equation that we're going to balance. H2. Okay, and Cl is one of the mighty 7, so it exists as Cl2. And then the arrow yields HCl. Okay. All right, so let's look at balancing this. And we're going to use what we call nanomodels so that you can actually see better how to balance this. Now, when you balance equations, you always start with carbon and you end with hydrogen, then oxygen. Okay, so there's no carbon here. We're going to end with hydrogen and oxygen. There's no oxygen, so of course we're going to end with hydrogen. So we're going to start with the chlorine. Now, this is Cl, 2 atoms of Cl here. So this is, when you balance an equation, you look at what you have as reactants, and it has to balance or equal out with what you have as products. So we see here we have 2 atoms of Cl on the left-hand side of the arrow, but we only have 1 on the right-hand side. So in order to fix that, we're going to have to add another molecule of HCl. Can count though. Oh, we have to put in a 2 here, saying that we have 2 molecules of HCl. Okay, so let's count. On the left-hand side we have 1, 2, and on the right-hand side of the arrow we have 1, 2. So the chlorine is balanced. So let's look at balancing the hydrogens. On the left-hand side of the arrow we have 1, 2 hydrogens, and on the right-hand side of the arrow we have 1, 2 hydrogens. So this equation is balanced. Okay, so let's look at another example. Again, we have nitrogen, which is diatomic. It's one of the mighty 7, combining with hydrogen, which is one of the mighty 7. So we have N2 combining with H2. This yields NH3. Okay, we're going to start with carbon and end with hydrogen and oxygen. Well, there's no carbon and oxygen, so we're going to start with nitrogen. So on the left-hand side, we can see we have 2 nitrogen. So on the right-hand side, we only had 1, so we'll have to add another molecule of NH3 to get our second hydrogen. When we do that, we have to add our coefficient, saying that we added a whole nother molecule. So now we have 2 molecules. So let's count our nitrogens. We have 1, 2 on this side, 1, 2 on this side. Okay, now we need to balance our hydrogens. Well, on the right-hand side, we've got 1, 2, 3, 4, 5, 6 hydrogens. And on the left-hand side, we only have our 2. So we need 6. So how do we fix that? Well, we add 2 more molecules of H2. Now, since we added 2, we have a total of 3 here, so we have to have a coefficient that reflects that, so we're going to put our 3 there. Now we count our hydrogens on the left side. 1, 2, 3, 4, 5, 6. We can see now the hydrogens balance out, the nitrogens balance out, so this equation N2 plus 3 H2s yields 2 NH3s is a balanced equation. Now our third example is a little bit different. Here we have HCl is going to combine with O2, and oxygen is one of the mighty 7, so it has to be diatomic bonded together. That's going to yield Cl2, again Cl is one of the mighty 7, bonded together, Cl2, you have to have 2 of them, plus H2O. So when we draw on our little nanomolecules, this is a HCl molecule, O2 molecule, Cl2, and H2. These 2 little spheres here represent the hydrogens. O, 1 oxygen. Okay, start with carbon. We don't have any carbon, and we're going to end with hydrogen, then oxygen. Okay, so all we have left is chlorine, so we're going to start with chlorine. So on the left-hand side, we have 1 chlorine, left-hand side of the arrow. We have 1 chlorine. That has to balance out with what's on the right-hand side of the arrow. We look over here, we have 2 chlorines. So we have to fix that by adding another chlorine here. And if we add a chlorine, we have to add the hydrogen that is bonded to. So now on this side we have 2 molecules of HCl, so we have to put in our coefficient to reflect that. Okay, now we're going to look at our hydrogen. Well, we have 2 hydrogen on this side and 2 hydrogen on this side. So our hydrogens are balanced. So we're going to end with oxygen. Well, on this side we can see we have 1 oxygen, but on this side we have 2 oxygens. So how do we fix that? Well, we can take away one of these oxygens. So if we do that, we have 1 here and 1 here. We have to put in our half of a molecule here. Now that creates a problem because oxygen is diatomic, and we cannot have half of a molecule. So let's think about this algebraically. How can we fix this using algebra? Well, if we take our equation that is now balanced, we can multiply this by something to get rid of this half. Okay, and what do we multiply by to get rid of this half? Well, we multiply it by its reciprocal, which is going to be 2 over 1, which is just 2. So if we multiply everything in this equation by 2, then we should have a balanced equation. So 2 times 2 is 4. 2 times 1/2 is 1, so we got rid of our half. But we don't write 1s as coefficients, we just leave it blank. 2 times, there's a 1 here, but we don't write it. 2 times 1 is 2. And again, 2 times 1 is 2. So we should have a balanced equation here. So let's go ahead and draw in our nanomolecules and make sure that we have the same number on the left of the arrow as we do on the right. So here we have 4 HCl, so we draw in 4 HCl's. We have an O2 here. We have 2 Cl2's, so we draw those in. And we have 2 H2O's. Okay, so let's count. We're going to start with chlorine. 1, 2, 3, 4 chlorines on this side. 1, 2, 3, 4 chlorines on this side. Okay, we're going to end with hydrogen, then oxygen. So hydrogens, 1, 2, 3, 4 hydrogens on this side. We come over here and we have 1, 2, 3, 4 hydrogens on this side. So far so good. Now we're going to end with oxygen. 1, 2 oxygens on this side. 1, 2 oxygens on this side. Everything equals, so that is a balanced equation.